Hello everyone and welcome to my section. I'm going to be talking about the analysis of WebAssembly as a strategy to improve JavaScript performance on IoT environments. My name is Fernando and I'm a PhD student in computer science at the Federal University of Pelotas. These are the outlines that I will be going through as the presentation progresses. JavaScript is a highly dynamic script programming language that has become one of the essential programming languages among developers. According to Stack Overflow, for 8 years in a row, JavaScript has maintained it as the most commonly used programming language, with an estimated community of 12 million developers worldwide. Initially, JS was designed for the web, and the vast majority of sites use JavaScript. But JS has been applied in other contexts such as server-side programming, mobile applications, games, and Internet of Things. IoT is a paradigm in which everyday object can connect to the internet and interact with the environment through sensors and actuators. IoT solutions are proposed in several segments. They have unlimited resources in terms of processor, memory, and storage, and they are typically battery-friendly. JS can simplify the programming of IoT devices because it is easy to learn and mainly by supporting event-oriented architecture. However, JavaScript is an interpreted language that can penalize applications in performance compared to compiled language. This paper evaluates WebAssembly as a strategy to improve JavaScript performance and measures the impacts of WebAssembly on IoT devices. WebAssembly is a portable bytecode that enables low-level code on environment types. The WASM module is compiled from the C, C++, Rust source code through a specific toolchain. The module has already undergone optimization during the compilation phase. Here we can see the common JavaScript execution pipeline. The machine code is analyzed in runtime to identify if something is running slow-mode or if there are bottlenecks. The problem here is this optimization uses CPU, hence implies power consumption. In the WebAssembly approach, JS uses the function exposed from the WASM API module, which is already optimized. Therefore, the looking for non-optimized code fragments can be skipped. We use Raspberry Pi 3B and Ostrich benchmark switch. We execution it benchmark 3 times, running the algorithm implementation in JavaScript and WebAssembly while collect system information. Toward this end, we use the perf tool and the in-house power meter based on INA291 sensor. Here we can see the results about the execution times. It's noteworthy that we included the results on the execution of C language. We had the algorithm and the results help us to evaluate the performance of WASM against the compiled language. In sum, the WebAssembly had a better performance than JS, in some cases exceeding 50%. However, WASM had the worst performance regarding the memory consumption, and we achieved high rates of standard deviation. Similar to execution time, the energy consumption was good. However, our measurements included the overhead of the operation system. Finally, this table shows the absolute numbers from each benchmarks. The table presents the comparative results of JavaScript against WebAssembly. In general, we achieve around 40% of improvements in execution time and energy consumption. In the same way, we have a positive number regarding memory use, but memory use is not so good due to an average of executions. Internet of Things and JavaScript can be used together. However, there are several challenges and opportunities to use JS language applied to IoT context. Furthermore, JavaScript is suitable to build a pretty stable, clean, and maintainable code based on modern frameworks and design pattern practices. The evaluation presented in this paper shown that WebAssembly is an efficient strategy to improve JavaScript performance, being superior in all evaluated items, emphasizing reducing battery consumption. On battery-powered devices with limited resources energy consumption can be more significant than the speed of execution. Finally, WebAssembly as a permission technology can be applied to different contexts, mainly because it is compiled code suitable for the IoT environment, optimizing the trade-off between performance and resource consumption. Thank you for your attention, and if anybody has any question, please let me know.